It comes from the joke, why was 6 afraid of 7? 7, 8, 9. Yeah, 7, 8, 9. Okay, similar figures. There's something similar. They're the same shape, different size. Same shape, different size. So basically, their angles are the same, but they have different lengths, measurements for their lengths. Angles are the same. Page 34. Lengths are different. Right, so you dealt with similar triangles before, back in the day. And you learned about the ratios of similar triangles. So the ratios of the similar triangles are the same. Like this, if you have a triangle that's 3, 4, 5, and this triangle, bigger, I'm running out of room, let's say he's 6, what would this guy be? They're similar. 8 and 10, right? They have the same ratio. So that triangle is going to be always 2 times bigger. That ratio is always the same. Congruent figures, however, are what? Exactly the same. You can almost think of them as clones because they're the same shape and size. Okay? So they're identical. Their angles are the same, their side lengths are the same, they are in every way the same. So next time you see identical twins, you can be like, you're congruent. And they'll be like, you're weird for saying math stuff. But you're like, we're going to make math cool. No? Okay, a vertex or vertex. What's that? For 2 point, yeah, the point where lines meet. You could also think of it as the corner, right? A corner point in any shape. Or you could also define it how Thomas did, about where 2 lines meet. I think that was Thomas. Or was that Brennan? Brennan, sorry. Where 2 lines meet. Brennan. Okay. Where 2 lines meet. The point where 2 lines meet. I know I'm going fast, but this stuff is mostly review. Okay, triangles add to 180 degrees. And squares, parallelograms, 4-sided closed shapes, 360. Very good. 360. Okay. Can I move on? Oh, we did that already. All right, you don't need this box. According to angles, there's 3 types of angles, and we're dealing with a triangle, 3 types of triangles. One of them, someone say it? Acute. Acute angle is like adorable. What is an acute triangle? If you have an acute triangle, Brennan, what's smaller than 90? What angle? All angles. Okay. So acute triangle is when all angles are less than 90 degrees. All angles are less than 90 degrees. So an example of an acute angle would be an equilateral triangle because they're all 60. They're all acute angles. Okay, if it's not acute, it could be obtuse. Remember these good old days? Yeah, it's like a long time ago. I don't know, there's a book? I never got a book. Okay, so obtuse means one angle is greater than 90 degrees. Is it possible to have more than one angle? No. You could try. It won't happen because angles are in a triangle add to 180. And so if one of them's over 90 degrees, the other 2 must be smaller combined than 90 degrees because it has to add to 180. Okay, and so the very last one the one that's the star of the show, the main act, is right. The right is right. The right triangle. Okay, so the right triangle, one angle is 90 degrees. The trigonometry we're going to learn in this unit only works for right angles, right angle triangles. If it's not a right angle, then we have to make one. Or you're in grade 11, you'll learn about sine law and cosine law. You'll learn a way to solve them. Okay? Yay! So, moving on. Choosing the right ratio. So, in trigonometry, there's 3 ratios. Okay? One of the reasons why there are 3 ratios, if I have a triangle and it has 3 sides, because it's a triangle, a ratio, what is a ratio? Describe in any way you can think of a ratio. 1 to 10 is a ratio, yeah? Give me another. 10 to 1 would be a ratio. So when we have ratios, we're usually comparing how many things? How many things are we comparing when we do a ratio? 2. We're comparing 2 things. So if I have a triangle and I have 3 sides, so maybe this is 3, let's do 3, 4, 5 again. How could I compare these 3 sides in the form of a ratio? We're comparing 2 at a time. How could I group these? Let me rephrase this. How many ways can I group these sides in groups of 2? Okay, in groups of 2, how many ways can I group these sides? So you could either do the 3 and the 4, right? You could do the 5 and the 3, or you could do 5 and the 4. There's 3 ways we can make a ratio, or we can compare 2 sides. Right? There's 3 ways we can compare 2 sides together. And that's why there's 3 trig ratios. So if you grab your formula sheets, on the front page, right underneath your conversion chart, there are your 3 trig ratios, which probably mean absolutely nothing to you right now. Yeah. They probably look like gibberish. Okay? So it's actually not pronounced sin. It's actually pronounced, does anyone know? Sine, yeah, pronounced sine. Cos, or actually its full name is cosine. So this is a sine ratio, this is the cosine ratio, and the tan ratio, or tangent, yeah, tan ratio. So any of those words look familiar to you? Okay, tangent. Well, tangent is not, okay. Okay, opposite might look familiar to you. You've seen one of those before. Hypotenuse, right? We've dealt with the hypotenuse. We know how to label a hypotenuse, right? The other 2 sides are going to have names now. They're going to either be opposite or adjacent. Okay, they too are going to have names. Okay, so when I was talking about this triangle, who would have been the hypotenuse? 5. Why would it be 5? The biggest number? Why else? It's not connected to the right angle. It's opposite the right angle. It's the hypotenuse. Okay, so a hypotenuse is always opposite the right angle. Opposite the largest angle would be the largest side. So the other 2 are going to have names too. Their names are either going to be opposite or adjacent. Okay? And it all depends on which angle we're looking at. We'll always have 2 acute angles in a right triangle. Why will they always be acute? Yeah, Thomas? Yeah, if you had 3 90s, I mean more than 180. This is 90, then we know these 2 have to add to 90 to make 180. So it's impossible for them to be greater than 90. Okay, so these 2 are going to be acute angles. So say if I was looking at this angle right here, do you want to take a wild guess who the opposite side would be? Wow, that was a really good guess. Why do you... Oh, it's actually because it's opposite of the angle I'm looking at. Okay? And if this is the angle I'm looking at right here, 3 then, by process of elimination, would have to be the adjacent side. You don't have to write this down right now. We're going to get into more depth soon. You will write it down eventually. I promise. Okay? So adjacent. Well, why do you think it'd be the adjacent? Why would 3 be adjacent to this? What does adjacent mean? Beside. If you're adjacent to somebody, you are beside them. So if this is the angle I'm looking at, notice how 3 is beside the angle. It's the adjacent side. Okay? So there are 3 ratios, and notice how there's 3 ways to compare the different sides. We could either compare opposite and hypotenuse, we could either compare adjacent and hypotenuse, or opposite and adjacent. So the 3 ways we can make the ratios of the sides. Now I will say with trigonometry, it's going to be a lot of information at once, but then it's repetition, repetition, repetition every day, and it gets really easy. Starts out off like a lot of information. Okay, so going back, choosing the right ratio. Well, the first thing you want to do is draw a triangle. Draw the triangle that you're dealing with. Or if you already have a triangle, you want to make sure you have you've labeled all the, like, you draw your triangle, you fill in all the stuff you know. If it's already there, then the first step's done for you. Okay? The second is once we have our triangle and all the numbers therein, the angles are in if we know them, then we're going to label the sides. Label the sides based on the given angle. And it's either going to be one of 3 names. We already talked about them. What are those 3 names for the sides? Opposite, adjacent, and hypotenuse. That's how you spell it. Hypotenuse. If you ever forget. Okay? So if you look at your formula sheet, once we've labeled our side, we need to figure out which ratio we're going to use. And how we're going to figure out what we use is based on what we're given. And on your formula sheet, I use a little acronym. So if you look, this is sine, S-O-H. That becomes so. C-A-H, ka. T-O-A, toa, SOHCAHTOA. You never heard that before? Sounds like you're soaking your toe, SOHCAHTOA. Okay, SOHCAHTOA. So that's going to help us so that you never really have to look at your formula sheet. And I'll show you what I mean. So going back here, we're going to determine which ratio to use. And we're going to use SOHCAHTOA. So I write it like this. It looks kind of strange. So it's based on the sides that are given. Okay? So for example, if I was given adjacent and hypotenuse, the only ratio with A and H is cosine. So then I have to use cosine. If I was given opposite and hypotenuse, I would use sine. Or if I was given the 2 sides, opposite and adjacent, I would use tan. Okay, the tan ratio. So let's get to labeling this triangle down below. So can you, based on the given angle, can you please label opposite, adjacent, and hypotenuse on that triangle? Does everyone have this down? No? Okay, so on this triangle right here, label which side's hypotenuse, label which side's opposite based on that angle, and which side is adjacent. I usually start with hypotenuse. It's the easiest one. Never changes. No matter which angle you're dealing with, hypotenuse is always the same one. It's opposite the right angle, right? longest side. Okay, then I like to use an arrow to figure out what's over there. Opposite. And adjacent. So the sign of an angle will give you that ratio of opposite over hypotenuse. The cosine of an angle will give you the ratio of adjacent over hypotenuse. And the tangent of an angle will give you opposite over adjacent. So why did they use the words sine, cos, and tan? Well, why not? Exactly. Okay, so before we start any of this, you have to actually be in the right mode. So your calculators are automatically in something called radian mode, which you will use in grade 11 and 12. But we need to be in degree mode to calculate degrees. So how do we do that? Well, we're going to push the mode button. That's beside the second, right at the top. If you have a scientific calculator, it should say DRG, degree. If it says rad somewhere in small letters, you need to switch it. Okay, so go down, arrow, make sure you push enter on degree, and it should be the highlighted one. To get out of there, I think you could just push clear. Clear is the easiest way, yeah. Clear is the easiest way, or second mode. Okay, how do you check? The easiest way to check to see if you have the right mode, tan 45, so tan button is right above the bracket here, pointing to it if you're unsure, and it should equal 1. The reason why, if you have a right angle triangle with a 45-degree angle, okay, this is a bad marker, I'm sorry, 45 and 45, what could you also call this triangle? No, it has another name. These two angles are the same. Isosceles. These two sides would also be the same. Okay? And so, if this is my angle of 45 and tan is the ratio of opposite over adjacent, well, if these two sides are the same, doesn't matter what they are. If it's 30 over 30, what does that equal? 1. Okay? So when you type in the tan of your angle, it actually gives you that ratio. Because that's why they're equal to each other. Okay? It equals the ratio. Tan of an angle will give you that ratio of the opposite side divided by the adjacent. Okay, moving on. Let's practice picking which ratio to use. We're going to do this together. I'm going to try and do this slowly. Okay, so we start off with an angle. They're going to either give us an angle or indicate that we are looking for that angle. So in this case, do they give us an angle other than 90? Yes, the 23. Okay, so based on the 23 degrees, guys, you want to put your calculators down for now? And just listen up, because I don't want you to miss out on this next part, okay? Based on the 23 degrees, what is side 12? What is it going to be called? So opposite. I'm labeling the sides that are given. So in this example, I would actually be looking for A because it's unknown variable. And they gave us 12 and they gave us 23 degrees. Okay, so we label the sides that are actually already labeled. What would be A? Yeah, something cool about the adjacent. Adjacent is always between your angle and the 90. The adjacent is between both. It's beside both the 90 and the 23, your angle. So using SOHCAHTOA, I look up, okay, which ratio has O and A, opposite and adjacent? Tan. Tan. Okay, this is essentially the same thing as what's on your formula sheet. Which one is opposite and adjacent? Tan. Okay, so that means I'm going to write the formula. The tan of an angle would give me the opposite over the adjacent ratio. That's the formula for 10. For now, yes. The reason why is students will often write this, which is incorrect, because they don't write the angle in there. They'll forget to, and so if you write it like this, you'll get in the habit of writing it properly. So now let's fill in what we know. The tan of what angle? 23. Everything's been based on the 23 degrees. Is equal to, so the tan ratio for 23 would be what divided by what? Opposite over adjacent. 12 over A. It's an A. We didn't know what it was. It's just a variable. Okay? So this is how we could set up a problem. Now we're not actually going to solve that right now. We're just going to practice setting up the ratio. Which ratio would I use? Based on the angle and the sides given. So this guy, which angle are we going to use? 34. Always an acute angle. Okay, whose hypotenuse, Adam? 24 is the hypotenuse, and what would x be? Okay, so if you want to label opposite next, you use your arrow. This would be opposite. And this guy, x over here, would be between your angle and the 90 is always adjacent, the side. Okay, so which side do we not need? Which one did we have no information given? The opposite. We don't actually need the opposite. No information was given. We want to work with adjacent and hypotenuse. So we look up who has adjacent and A and H? Ka. Ka. So, yeah, it's like a bird. Okay, so cos of our angle is equal to adjacent over hypotenuse. So let's fill in what we know. Okay, cos of what angle? 34 equals, hey guys, enough cawing. We're past the cough. What divided by what, Wyatt? Okay, adjacent over hypotenuse. Who's adjacent? Okay, what is he called? He's just x. Okay, so x divided by what? Who's our hypotenuse? 24. Okay, does it look still kind of like gibberish? Yeah, it will for now. It's the most confusing in the first day, and then it gets a lot easier. We will solve. Not yet. Not yet. Okay, we're just practicing choosing our ratio. So let's just choose our ratio for the last two. We won't, I don't know, well, maybe we'll write it. Okay, so 16. Let's label this given sides. What would x be? Opposite. And that would make between the right and your angle is? So which ratio has opposite and adjacent in it? 10. Tangent does. Tangent is opposite over adjacent. Over A. TOA. Okay, so tan of 16 degrees would equal the ratio of x over 12. X over 12. Okay, try the last one on your own. You can do it. No. You can do it. No? Okay, so what's 19? That would be opposite. What would be x? Hypotenuse, because it's opposite the right angle. It's alongside. Okay, so which ratio has O and H? What's wrong? Stop. Pause. What's wrong, Thomas? Up. Hypotenuse is opposite the right angle. Okay. Okay, so, huh? Okay, so opposite of the 42 is the 19. Okay, so then we would use the sine ratio, because that's opposite over hypotenuse. Sine 42 would be 19 over x. You should have had written down. Now, I have good news for you today. We're only going to work with tan today. So we're only going to work with, in your homework, the opposite and adjacent, those two sides. Okay? So we're going to pretty much work always with triangles like this, where we don't know the hypotenuse and we're not worried about the hypotenuse. Okay? So we're going to just focus on that, and we're just focus on how to find the angle given the opposite and adjacent. No, are you okay? Yeah, are you in a food coma? No? Yeah, I know. It's warm in here. You're hungry? Oh, wait. Did you not eat? You didn't eat? Oh. Okay, let's go through an example. Can you put this as your unknown angle? Do you remember that symbol? What's that? That's an unknown angle. It actually has a name. Yeah. Theta. 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 Sounds like a type of cheese. Okay, guys. Guys. Focus. Okay, can you please label this side 7 and this side 9? Okay, so let's label these sides based on our unknown angle. I want to find this unknown angle without using a protractor. Okay? So what would 7 be called? Oppo, opposite, and 9 between our angle and the 90, beside, adjacent. Okay, so what ratio would have O and A? If you're not sure, grab your formula sheet. You can either figure out from there tan, or you could also figure it out from our good friend SOHCAHTOA. Sounds like another language. SOHCAHTOA. Okay, so we're going to use the tan ratio, so let's write out the formula first. Right, and that's on your formula sheet. Well, we're going to find it today. We're going to figure out what it is. So that's the unknown angle we want to solve for it. Okay, so does everyone have the formula written down? Shh, guys, don't make me put you in a seating plan. Okay, so do we know our angle? No, so we're going to leave that as theta. Okay, so opposite side is 7 divided by adjacent side is 9. Now, here's the problem. I want to get the angle by myself. Okay? There is no such thing as dividing both sides by tan, because these are not being multiplied. It's not tan times theta. Tan is not a number. It's not a variable. Okay? It's an operation in itself. And in your calculator, boys, that's enough. In your calculator, all these ratios are stored. Okay? And no matter what, given the rate, because of those similar triangles, the ratio of 7 over 9, the tan ratio of 7 over 9, always gives that same angle because they're similar triangles. So the opposite of tan, if you look on your calculator, because I want theta by itself, I want to get rid of the tan. If you look above tan in yellow, see the tan with the -1 there? That's called inverse tan. So what happens is if we take the inverse to both sides, I'm going to take the inverse of both sides. What I do to one side, I have to do to the other. Okay? So we're going to take the inverse to both sides. It looks confusing. But what happens is when you take the inverse of tan, the inverse tan of tan, basically you're just left with your angle. So in order to get our angle, given our ratio, we always have to use inverse tan. So tan inverse how do we plug that in? Well, I'm going to actually write down the keystrokes. So the keystrokes are, so to get the inverse tan, we push second. Turn on your calculator. Second. So you want to push second, and then tan 7 divided by 9, and then enter. Okay? So second tan, 7 over 9, enter, is 38 degrees. Did anyone not get the same thing? Yeah, you're in the right ratios, right? Did it work? Do you want to try it, just in case, because your calculator's different? Okay. Anyone else, anyone not get that answer? Should all be trying it. Because if you're not trying it, then when you get to trying it on your own, you didn't? Okay, so you're in the wrong mode. Where's your mode? Right there, mode. So you have to go over to right down here, radian, change that to degree. Okay, where's escape? No, I don't want to cancel. I want to push enter to save it. You change it. Oh, you have to use inverse tan. Inverse tan. So it's this button, second tan. Okay? Yeah. Sure. Yeah. Okay. Oh yeah. I'll talk to them after. Guys. Okay. So did everyone get 38? Was it 38 degrees? Okay. So that's how we solve for an angle. You might want to add this to your study sheet. Whenever you're looking for an angle, no matter what, we always are going to have to use the inverse function. Okay, that's really important. If you're ever looking for an angle, you're going to have to use inverse. So we were looking for an angle, we had to use inverse tan. Okay, so moving on. Let's a couple examples to go through still. Yeah. You have lots of time. We're not going to have a quiz till next Wednesday on it. Okay, guys. Shh. I need your attention. Guys. Okay. Okay. So here we're going to draw this tan ratio of 3 over 5. That's what they want us to use graph paper and draw this ratio of 3 over 5, the tan ratio here. So we need to know what each one of these, the 3 and the 5, stand for. So with tan, it's SOHCAHTOA, 3 would be what side? The opposite. So opposite of A, and 5 would be the adjacent of A. It's always easier to start with the adjacent. So we're going to draw this angle A. So what we're going to do is put a little dot for where your angle A vertex is going to be. Okay, so we want to do the adjacent side on the bottom, because adjacent means beside. So 5, we're going to go 5 units to the right. I'm going to use every second space as 1. So 1, 2, 3, 4, 5. Okay. Thank you. And opposite of A would then be the vertical side, because we want an opposite of our angle A. So 3 units up. 1, 2, 3. So that would be angle A ratio. Okay, so that's the diagram. So they gave us tan A equals 3 over 5. What if I wanted to find angle A? How would I find angle A? Inverse tan of the ratio. Okay. Inverse tan of the ratio. So second tan, 3 divided by 5.
Senior boys volleyball players, please come to the atrium now.
Okay, so if we drew this perfectly, we should be able to take a protractor and actually measure 31 degrees. That should be a 31-degree angle there that we just drew. Okay, so let's skip this one. It's the same thing as what we just did here. How about this one? Tan A equals 0.2. Does it look like a ratio right now? Could we turn 0.2 into a ratio? Yeah, all decimals can be ratios. 20 out of 100, or 2 out of 10, or 1 out of 5. Does it matter which one we use? No, they're all the same. They all equal 0.2. They'll all give the same angle. I'm going to use 2 over 10 because I know this is 20 boxes total. So if I use every 2, that would be 10 across. Right? Again, 2 is opposite and 10 is adjacent. So up 2. And there's my angle A. You should have 2 is opposite, 10 is adjacent. Okay, so sometimes your ratio can be disguised as a decimal, but it still is the same thing. So how do we get our angle A? We always use inverse. So we move the tan to the other side. We have to actually use inverse tan of our ratio. You could type in 0.2, or you could type in 2 over 10, or 1 over 5. It would all be the same. So second tan, 0.2. That's our 11-degree angle. So this here is 11 degrees. 11.3 actually. Okay. All right, the next example there. It's really important. It says, determine the tan ratio for all acute angles. So first of all, whenever you hear ratio, what do you think? Comparing two things. And so in high school, whenever you hear ratio, I want you to think fraction. Okay? So whenever you hear ratio, think fraction. So they want the fraction. Determine the tan fraction for all acute angles. So which angles are acute? D and F. These both are acute angles or less than 90. So they want us to find the tan ratio for angle D and the tan ratio for angle F. We're going to find both. And so basically, tan ratio means we're going to find the fraction. Okay? So let's looking at D, the tan ratio, we want what divided by what for tan? TOA. SOHCAHTOA. So we want opposite over adjacent. So for angle D, who is opposite to angle D? 3 would be opposite to angle D. So 3 divided by, who would be adjacent to angle D? 4. 3 over 4. Okay, so there we go. We're done. That's it. They wanted 3 over 4 for D. Angle F, tan of F. So again, the tan ratio is always TOA, opposite over adjacent. So for angle F, who's opposite to angle F? Would be 4. And who's adjacent to angle F? Would be 3. They would be, yeah. Yeah, they'd always be inverted. For tan, yeah. For tan. Okay, so that does not always the case for cos or sine, just for tan. Is there anything else I need to show you an example of? I think that is it. Is there an example like that there? Instead of going through this example, I want you to get started on some homework, but can you just write a little definition here really quickly? Just draw this diagram. So if it's asking about angle of elevation or angle of incline, the angle of incline is always from the horizontal up. Okay, starting at the horizontal. So if this was my triangle, that would be the angle of incline. Okay, down there at the bottom. Okay, it's a lot of it, like 3, for example, is just writing the ratio. 4 is just really quick inverse button. Some of it's really quick, okay? For your homework, remember that when will the quiz be on this? Wednesday. So this is theoretically not due till Wednesday. Okay? So Wednesday this is due. Okay, that's when the quiz is. So you can start your homework now. There's not tons of time. Class started late today. They forgot to ring the bells. Darn. Right?